Okay. Dzień dobry. Hello. Welcome in Shanghai. Sorry for the little. Sorry that we are starting a little bit late, but we had some technical difficulties. And well, welcome to our presentation. Today we would like to finalize our series of talks about configuration of Jenkins and testing the Jenkins itself. Today with the focus on communication between Jenkins and Gerrit. Okay, but before we start, it would be good to introduce ourselves first. Roman, can you start?
Sure. So I'm a Python developer for a long time. Also, I'm like in the 8-bit machines fan, so like the Commodore 64 or Amiga computers. And also I am a long time Gentoo user. What about you, Shimon?
Yeah, when it comes to me, I'm also IT geek. I love automatizing things, so that's why I work with Jenkins and Bash mostly. And I also love Italian dishes of all sorts. That's about me. And besides my work at OVH, I also teach at Wrocław University of Science and Technology. Well, we both were used to work at OVH. Now it's only me. Roman decided that the better hat suits him better. But at OVH, we are responsible of taking care of OpenStack services, from developing our custom extensions to packaging it and deliver to the production. For this, we used Jenkins. And this is why we are on this talk. As I already stated, this is not the first time we are speaking about this topic. It's the third and, we hope, final part. We've been speaking in Berlin and in Denver. So the slides will be available after the presentation. If you missed them, you are welcome to watch on the OpenStack Summit pages. And for those who were absent or missed them simply, Roman will do a quick summary, quick recap of what was there.
Okay, so Jenkins is a automation server for deployment or the testing things, so you can just do whatever you like with it. So it's like a powerful and extensible server for any automation you need. And it's open source, so you can use it. It's actually widely used by a lot of companies, like you can see on the slide. Also, we have, because the Jenkins configuration is like a GUI click thing, so that there are plugins which you can use for doing the automation of the configuration of the Jenkins. It's like an oxymoron here, but yeah. So you can use the configuration as a code, and there are 3 plugins we are using at OVH. So the configuration as a code, JobDSL, which is a plugin which you can do your definition of the tasks or jobs or whatever in Groovy, and job pipelines, which are like steps for the jobs. And last time we are talking about verification of such configuration. So the Jenkins configuration as a code can be validated against the JSON schema. JobDSL can be tested by using the regular Groovy parser. And also job pipelines can be checked by built-in parser. So yeah, and additional things need to be launched for completeness.
Yeah, and speaking about those additional things, what we are missing is that whenever you check that your configuration is valid according to some specification, according to some schema, you still are not actually sure that what you configured is doing what you intend to do. Okay? This is one example. Second example is that you may hopefully welcome new team member at your work, at your team, and this team member will have to get into all your scripts, all your workflow, and eventually will modify it. Okay? How you can be sure that after introducing some change to the current workflow, if someone is not well aware of it, it won't break everything. Okay? So this is the idea of the testing. We need to functionally check whether everything we want to conduct is correct. Okay. In this presentation, we were talking about Gerrit particularly, and so far, during the last two presentations, we didn't mention actually what Gerrit is because it was like side topic. So it's good to define it here if someone is not aware. Gerrit is referred as code review platform. You might look at it as like for GitHub or GitLab. So there is Git repository because Gerrit relies highly on Git, but the focus is to provide collaboration tool with focus on clear changes review. Okay. A bit of history. It was created by Google at Google to originally to make better review of changes in Android operating system code. Actually, it's not the first tool that was created. Originally, there was the tool called Rietveld, however you speak that. It's from Danish architect, last name. However, there are two rumors. I'm not sure if which one is true, yeah. Why this system was not used anymore. First is that it was designed for SVN. Second is that the development of the system was too slow for developers, for people that wanted to work over Android. So they created a fork, rewritten it from original Python to Java, and this is how we know Gerrit today. And in the recent version of Gerrit, started version 3, it's completely Git-based. I mean, previously in version 2, it was relying on SQL database. Now everything is stored in something called NodeDB. It's a database based on Git files. Very fancy idea. Okay, and to answer our question, we stated how you can ensure that everything you specified in the configuration works as intended. Well, the obvious solution is to add Gerrit. And if it works for you, if you can prepare Ansible files, configure everything, trigger proper jobs, and before to triggering jobs, configure repositories with some example codes, that's fine. We can finish our presentation here and say thank you. However, of course, this is not a perfect solution because of the Gerrit itself. It's a very powerful tool, actually, and because of its powerfulness, it is quite heavy. To run it smoothly, you will need some dedicated resources, ideally, at least some gigs of RAM because it's based on JVM. And then, of course, configuring all that things, putting repositories, setting permissions, maybe some firewall if it's a real Gerrit instance, it might be very time consuming. Okay? So if we look at our problem, we might start to think, do we really need all of that? Because what we are really looking at is how Jenkins see the Gerrit. And the most important thing is it's stream events, like what happened in Gerrit, not the state of the Gerrit itself.
Yeah, and from that idea, we start thinking about faking the Gerrit with something else, and that's how the Ferret project arrived. So The ferret itself is a Python library or Python program which can be deployed easily, and it's have only two dependencies right now. So the first one is the Paramico, which is for the SSH part, and the other one is the Bottle, which is a micro framework for the REST API. And it's easy to deploy, and it's fast, and probably would fulfill our needs for let's say, speaking between the Gerrit or ferret and Jenkins. So this is how it looks like, the communication. So the ferret itself consists of the two things, as I already mentioned, the SSH server and the REST. So it's a web server which talks about with the API of the by the REST. Sorry. So the idea here is that we could talk to the Jenkins or trigger Jenkins using the stream events, which would be sent by the SSH through the let's say the REST server, which will take the request. So for example, if I would like to create some event which should go to the Jenkins, I would just curl to the Python web application, and then it will be write to the FIFO queue, which will be read by the SSH part and will be sent to the Jenkins. So Gerrit itself provides us two layers, two communication channels, let's say. So the first one is the REST API and SSH commands. And also the Gerrit functionality can be extended by plugins, like, for example, stream events, or that there is a lot of them.
Okay. And and about the connection between Jenkins and Gerrit, in most typical situation, use well-known solution already. It's called the Gerrit-Trigger plugin for Jenkins. It utilizes the mechanism provided by stream events plugin, so you need to install it in Gerrit. This plugin exposes all actions that are happening in Gerrit over SSH CLI, and there are many things that are reported, like comment was added, some reference was updated, some change was merged, some change was proposed, etc., etc. And many of these events are positively catched by the Gerrit-Trigger plugin. Some of them are listed, like I already mentioned, patched created, comment added, change merged, abandoned, restored, and some others if the Gerrit server supports them, like publishing drafts or topic changes.
Yeah, so as for the SSH server, actually a service for the ferret project, it is right in Python, implements the SSH protocol. I mean the Paramico, which is used by it, and probably it's not wide used for actually doing serve the SSH server. It's mostly used for communicating with the SSH servers like on your infrastructure. But we were using it for building our, let's say, fake Gerrit server SSH. So this is the a code example how we done it. So it consists two classes. The first one is SSH handler, which is using for to create the transports. So the line 8, which is highlighted there, is create the transport which starts server, which will be the other class I will show you next. And we are doing simple while loop, which will handle the server commands. And if we have the Gerrit stream events command, then we will try to read data from the FIFO queue. And as for the server, this is the Paramiko server interface, and it's look more or less like this. And especially the check channel exec request, we are going to catch the command, and if there is a command we are looking for or have supported, then we are going to set it.
Okay, right. So for the remaining part of Ferrit, for the REST API implementation, we use the Bottle framework. You might know more famous alternative called Flask. Bottle is a very simple designed to be a single file module that is designed to create web application, web services. And apart from its simplicity, it has so many features that are optional, like templating support from Jinja, Meiko, and Cheetah. And also it has some already built-in utilities, like it allows you to process the data coming from forms or some headers and cookies handling, parsing. For our scenario, we would need just the simple usage of this library. Basically, everything you see on the slide is used in the official, the full application. This is just simplified to the 3 main routes. What we do is, at the end, how we start in Python, we run our application that is defined as a class that is inherits methods from the Bottle class. And there, in the constructor, we define some routes where the incoming requests to what method calls should be redirected. Okay. So just to explain a few things, the first plugin/events log. This is the endpoint used by Gerrit-Trigger to verify at first if there is even stream events plugin installed on the Gerrit. So we don't have to return there anything basically, except for 200 status, saying it's okay. What we return doesn't matter there. Then the project list, as far as we noticed, is that it's used to cache some names of projects to highlight them in Jenkins UI when you type or specify some jobs configuration. And then there is a last method we show here. It's the post method we used to support requests from terminal or some application to create an event that will be sent to Jenkins, like there was patch set created or something. Based on some templates we store in variable called events. It's dictionary. It's too big to show it here. And what we do, as Roman said, the SSH server, before serving it to Jenkins, it reads them from queue. So here we open this queue and write the templated JSON events there.
Okay, so how to get the Ferrit? So this is open source. You can grab it from the GitHub, as you can see. And installation is easy, like just pip install project and just go with the Ferrit. So this is like the simplest solution. Of course, there are other ways for launching, for example, for developing purposes. So you can just run those two servers separately, so you can see the logs and you can put your breakpoints, for example, there. So yeah, and for creating events for the Jenkins, it's simple as a curl for the HTTP server or HTTP part of the ferret. So you can just curl it with appropriate parameters, which stands for this, the parameter for the curl. So where to look for the results? Currently we are using a log file for grabbing the response from the Jenkins. So while you can make the curl for this server, then all of the response will go to the logs. So you can just see what's in there or parse them or whatever. So this is the like functional test actually for our use case. It's like usual unit test test. So all of we are doing is getting the result, which send and get response method on line 6 is like hiding behind. There is a lot of like things for querying the HTTP server from the ferret and getting the response, and then we are just go to the to see what happened and if the result, which is JSON actually, is look good, then we are fine. So basically that's it.
Okay, and here's the part we were going to surprise you, to show you something spectacular. Unfortunately, due to some unexpected events, there is some fancy technology, fiber to the screen. Sorry, we cannot present that to you. Maybe it's better because we are still like hit by the jet lag. Our brains are shouting, dude, it should be 4 a.m. Why it's so bright out there? Why you are not sleeping? Yeah. So, but we will give you the link to the ferret repository. There is README file, and if you work with Jenkins, you should be able to do exactly what we wanted to present here. There is the directory called tests, where you can find 3 example tests, and of course the ferret implementation itself, so you can launch it and basically simulate you have a real Gerrit working there and sending you some events.
Or alternatively, you can just bug us to show you the demo. So
yeah, so just privately, let's say. Okay. So after the demo, I wanted to make some conclusion, like where should be the end, how much you should test, what's the end of the line where you can say it's enough. Okay. It really depends. I would propose to distinguish 2 scenarios. First is that you are testing some project and there is something incorrect in this project. Okay, there might be some call to the non-existing function or something. This is the project case, and for us as the CI guys, this is not interested part in this topic. Okay. On the other hand, in your jobs, you might use some other source code to build a package or to actually trigger the tests, so launch them by, as in OpenStack projects, calling talks. And there you might generate list of parameters or something, and this generated list of parameters might be incorrect. This is what we want to avoid. This is what we want to test and prevent that changes in configuration will not affect launching some jobs. Okay? And the idea is here quite simple. If you want to test something, you need to have specified standard how you do things. Okay? It's good to look at OpenStack here because OpenStack projects are well standardized. Basically, all of them use docs for tests. All of them have this bindep.txt file where you can specify additional non-Python dependencies that should be installed to use this project, okay? And so on and so on. So if you specify what resources you have, what you need to install, what you need to fetch first, what scripts you use, then you can create a sample repository with some references and then use just this simple repository to test changes on it, okay? What's the goal here? You can imagine you will test Neutron, okay? In Neutron, launching tests can take, if you run it on single core, even over an hour, okay? It's a long time. But what you need from the testing the CI system is basically to know if you called the tox or some other Python or some other tool correctly, right? So you don't need the exactly Neutron source code. You may just have the simple single test hello world that will ensure you your script, your modification in your pipelines didn't affect the launching of the tests themselves, okay? And our final goal was to implement feature in Ferrit that it will be able to supply such sample repository. It's not ready yet because, as we found out, the Git protocol over SSH is a bit more complex than it seems. However, we expect it will be added in the near future. Okay, and as a last final word, I would like to point your minds to alternative for Gerrit-Trigger. We just found about it last week during preparing the slides, and it seems like a promising. Let's be honest, Gerrit-Trigger has some limitations, it has some flaws, and some of them are more irritating, some of them are not. Like, for example, if you change Gerrit-Trigger configuration, sometimes you might need to restart Jenkins to make it work. There is some bug, we faced it. And there are also some scalability issues due to stream events involved in the process. So that's why last year, some guy started a project called Gerrit Code Review plugin in Jenkins. So far, it's not that popular like Gerrit-Trigger. The proportion is like 1 to 10 in the best scenario. But as I said, it's promising. It's not stated as fully replacement for Gerrit-Trigger, but maybe for some simpler workflows, it will be sufficient. And yeah, so spread the word and check it out if you are working with Jenkins. Maybe it's something good. The one neat thing that it promises is the good support, good integration with Jenkins pipelines, Jenkins files. Okay, and that would be it. As a last word, as last slide, I just like to encourage you to do tests of everything. You might hit such the excuse, let's say, you will never be able to test everything, so why even bother? However, it's not the point of the test is not to cover everything, every scenario. Just calculate what's the pros and cons. Maybe in some cases you are using, in some corner cases you might face, they won't save you, but there might be simpler scenarios like I already introduced. There will be a new guy in your team, some intern, still learning, still playing, and if you want to back up yourself, it might be worth to implement even a simple test, not the whole world scenarios, okay? We won't build our own power plant to check what will happen in the case of lack of electricity, right? But maybe if you really depend on the electricity, you will need some some battery supplies or some alternative source of energy, and you should also test it if it's will work in the bad day. Okay.
So yeah, this is what we got for you today. Thank you for your attention, and thank you. Dziękuję. Okay.
We have
Are there
time for
any
questions?
questions? Maybe?
Gerrit as a code review at the end, right? And can you briefly explain that how does your workflow look like? So you commit a code, then it's go to Git, I guess.
Yeah.
Then will be triggered by Jenkins.
By Gerrit, actually. So the workflow is like this. It's very the same as there is in OpenStack projects. So if, for example, there is some bug or feature which should be implemented, then the developer works on it, doing the commit for the Git, and there will be the review. So after the developer do the review, then the changes goes to the Gerrit, right? And then Jenkins will be triggered by the Gerrit-Trigger plugin to do the tests.
Do the test, right?
Yes, it's going to do specific things, like, for example, if there's a Neutron project, so it run the talks, just like this. And it will send back the result to the Gerrit, and we will see if the changes was tested correctly or not.
So if I can understand it correctly, that it's like the Zool used in the
yes, the
OpenStack,
Zool
right?
is the other CI/CD tool for doing the tests, right?
So in your case, that the Jenkins will run all the tests and also give the results back to Gerrit, and in the Gerrit you will see those tests if they are successful or failed.
Yeah.
Okay. Yeah. Thank you.
We can say that Jenkins is a simpler alternative to Zool. Basically, the OpenStack community was using Jenkins before they developed Zool like it is now. And for that, we'll have a talk tomorrow. Are there any other questions? Okay, if not, so finally, thank you for your attention.
Thank you.
Dziękujemy bardzo.